Welcome back to another Melon Auto Diagnostics video. Hope everybody enjoyed their holidays. Today we have a 2008 X-Terra, and the complaint is check engine light is on. Alright, so we went ahead and scanned this vehicle, and as you can see, we have two codes. We have a P1148 and a P0031. The P0031 is an air fuel sensor 1 heater circuit code for bank 1, and the 1148 is a closed loop bank 1 fault. What I believe is going on here is some kind of air fuel sensor issue, so the computer is not able to go into closed loop. So I think that's why we're getting that P1148. So I'm actually going to attack the P0031 first, and we'll see if it fixes both issues. Alright, so as usual, you guys know I like to do my diagnostics mainly from the driver's seat before I even go out under the hood or under the vehicle. Looking at some data here, you can see I have the oxygen sensors pulled up, the voltages. I have my alphas, which is equivalent to fuel trims, and I have my air fuel heater commands for both bank 1 and bank 2. As you can see, bank 1 is 100%, and that's where our fault is. Our fault code is for bank 1. Bank 2 is hanging around 44%. So what that tells me is that the computer is possibly just trying to command this thing on right now, being that it's seeing no changes in the air fuel sensor voltages. Bank 2, you can see, is kind of just actually I can put this on a graph. Let me see here, let me scroll down so you can see bank 2. You can see the I'm gonna give the vehicle some gas now too. You can see we go fuel cut, and bank 1 is not reacting whatsoever. So is this an actual heater fault, or is this something maybe with the signal lines? I do think the computer detects when it detects the air fuel sensors not switching or not reacting, it does throw heater codes. I have seen that. That's why I'm saying that, but that may not be our case here. So here we are, connector F65 air fuel ratio sensor at bank 1. We have 4 pins: orange, light green, green, and white and red. So our pins 3 and 4 are our heater circuits. So green is going to be our heater ground, white and red is going to be our heater power. And the way this is laid out is this is the back of the connector. When you see, well, at least for Nissans, when you see 2 lines on the connector, it means you're looking at it from the back side. So our pins 3 and 4 are going to be our bottom 2 here, looking at it from the back side, not, turning it around. So let's go under the vehicle and make some checks and see what we got. All right, so bank 1 air fuel sensor is actually under, this is the right side of the vehicle, so it's under the fender liner here. So this is our sensor, and our connector kind of hides in here. I have it unclipped right now. I don't know if you guys can see that. Yeah. So typically, and this is across all brands, I believe so, don't take my word on that, but our 2 black wires are going to be our heater circuit. So all I want to do, heater circuit is pretty simple. We have power, ground, and that's pretty much it. We want to make sure that these wires are able to carry amperage to the sensor, and if we do have voltage here, then we know the circuit up to the sensor is fine. I also want to, depending on the results, I want to measure the resistance in the air fuel sensor. So I want to see if it's completely open or what's going on. So I'm gonna take some voltage measurements now at those two wires and see what we have. We were commanding this heater circuit at 100%, so we should be energizing right now. All right, so we're back probing into those two black wires there. That's our heater circuit. I want to make sure that we're getting voltage, and it shows that we actually are. We're reading 13.8 volts, which is battery voltage charging at this point. The vehicle is running, so that's why you're seeing 13.8. I'm gonna hook up a low amp test light in parallel with this. I want to make sure that we are able to maintain that voltage. I also want to do a resistance measurement on the sensor itself, so I'm gonna get the oh, this thing won't stay on there. Come on. All right, so I'm gonna get the low amp test light and see what we got. All right, so I have my low amp test light here hooked up, and we're holding around 13.7. So we're losing very, very small amount of voltage. Honestly, I'm not worried about that. This is enough to turn that heater on and hold it steady. I don't want to go higher in amperage right now because I don't know what else I'm feeding into, what else is part of that circuit that I'm just gonna hook up and light to. So I'm keeping it safe right now. I'm using low amps, but this is good enough for me. I think this is maybe 1/4 of an amp if I'm not mistaken. I'm not sure, but I know it's very low. This tells me that the wiring and wherever those two feeds are coming from, they are able to hold amperage, and yeah. All right, so I actually had an idea. I'm thinking this ECM is obviously monitoring, or actually it may not. That's actually what I want to know. Is the ECM monitoring this circuit itself? Because if it is, I should have checked the wiring diagram and seen where those wires go to. But if it is, this should actually make that code go away, because the voltage is not going through the light, and it should not be reading an open right now. So I want to go back and check the scan tool and see what if we can maybe see the code go past, or whatever. So yeah, I want to do that now. All right, so I'm back in the vehicle, and we're still commanding that heater circuit at 100%. So I think it may go off of just this signal voltage here, being that it's not changing. Once we heat up that air fuel sensor, we should be able to start reading our actual mixture. So I think, being that it's seeing that 2.2 stuck, it's not letting off of that command on the heater. So all right, well, we tried. So okay, last thing now before I call this air fuel sensor. Well, two more things actually. I want to measure resistance. I should have done that while I was down there, but I want to measure resistance on the actual heater circuit of the sensor, and I actually want to check our other two voltages. I'm gonna figure out a spec here for you guys, and I'll let you know. So all right, so going back to, oh my god, I just keep doing that, huh? Sensitive screen. Is this it? No. What? This is just gonna be a video of me scrolling through my service manual all day long. All right, so here we go. Bank 1 pins. I'm reading just to make sure I'm not on the heated, on the oxygen sensor downstream. All right, so we have pin 2 and 3, which go to pin 2 and pin 56 of the ECM. I want to see what we're supposed to read there. I'm sorry, not pin 1 and 2. Pin 1 goes to 35 and pin 2 goes to 56. So I want to see what we're supposed to have here. I'm gonna make those checks at the sensor, and then we'll go from there. All right, so here we go. 56 light green wire, ignition on, 2.2 volts, right? And then our other one was pin 35. And pin 35, we're supposed to have orange wire, approximately 1.8 volts, warm up condition, which we are warmed up. And RPM 2000, I think we should be good. And idle, I'm not really going too crazy with this. I'm looking for 1.8 and 2.2. So 2.2 minus 1.8 is 0.4. So yeah, that makes sense. About 400 millivolt difference for the sensor to swing up and down. You got to be careful with that too, because if you're looking for 2.2 volts, you might get thrown off by seeing the 1.8 on this wire. The data actually shows 2.2, but it's not. It's actually this is data that's not shown on the scan too, but it's actually 400 millivolts, just like an old school O2 sensor. The only difference is it's more precise. It doesn't have that oscillation. You know, it kind of tries to stay at that 450 millivolt mark, which is just the characteristics of the near field sensor. I'm not gonna go too deep into like how it works and all that, but yeah, that's pretty much. I hope I'm not confusing anyone, but yeah, it's 2.2 volts on one wire, 1.8 volts on another. You have a difference of 400 millivolts, and that 400 millivolts, it's what the sensor is using to actually, you know, measure air and fuel mixture. And that's what the computer sees, but the computer actually puts out 2.2 volts on the scan data. Let me see if I can go back. So yeah, you see here, like, let's use the good one. It's using 2.1. So it's not actually swinging on a 2.1 scale. The actual physical sensor. This is just a calculation by the ECM, and that's what it's putting on the data. But that's not the actual voltages down at the sensor. All right, if I'm wrong, please tell me. I don't know everything. This is just my assumptions on how this works, and just kind of common sense, I guess. So let's go down on the sensor and make some final voltages checks and resistance checks, and then we'll take it from there. All right, so before I check the voltages on those other two wires, I'm gonna measure the resistance of the actual the air fuel sensor. So I want to see that heater circuit internally and see what it's measuring. I'm pretty sure it's gonna be open, but we're gonna do that now. What I'm gonna do is I'm gonna unplug the sensor, being that I'm back probed into the sensor half. Sorry for the glare here, by the way. Yeah, I'm on the back half of the sensor and the connector there. So I'm actually going to unplug it, leave my leads right where they are, and then we're just going to switch this over to resistance measuring. All right, so we have the sensor unplugged. We're back pinned into these two black wires here. Back probed, I'm sorry. And we are reading open. So that heating element in the sensor is definitely open. Yeah, so I'm just gonna pierce these wires, because getting those back these probes in there with this connected is pretty difficult to do. I've already burned myself twice, so I don't want to do that again. I'm just gonna, I mean, we're confident at this point. We're almost 100% that the sensor's bad, so I'm not ashamed to actually pierce these wires right here at the sensor. That way I don't have to go all up in there and show you guys at the same time. So I'm going to remove my leads now and plug this thing in and do our final checks at those two other signal wires. Alright, so we're pierced on those two signal wires right at the air fuel sensor here. Again, I'm almost confident that this sensor is bad. I mean, we saw it on the reading regardless. We have to replace it even if we do have a wiring issue, being that our heater element is open. So you can always have more than one issue, which is fine, but at this point I'm not afraid to pierce the wires here, and regardless, I'd fix them anyways. I always put either liquid electrical tape or nail polish, which is pretty much the same thing. So we're at the first wire, which is our white wire, or I forget what color it is, at the connector. But we're reading, let's switch this back to volts. We're reading 1.8. Okay, so this was our 1.8 wire. Let's switch over to our blue wire. I'm assuming this is our 2.2, and it is. So we're good as far as this goes. Our signal wires are good. We have voltage coming all the way back to the air fuel sensor here. At this point, I feel extremely confident to call an air fuel sensor on bank 1. We'll obviously give the option to replace both of them. If you guys want to see a after repair video just to kind of see the data and all that, please comment and let me know. If not, I'll just leave it here. Like I said, it's 100% confirmed this needs an air fuel sensor. Yeah, so thank you guys for watching. Don't forget to like, subscribe, and comment, and see you on the next one.